This demonstration is on multi-layer switching done in Packet Tracer. Now in the CCNA, mostly we deal with layer 2 switching, where we configure VLANs on layer 2 switches, and if we want to communicate between those VLANs or route between those VLANs, we need a layer 3 device like a router. So you're going to need some switches and you're going to need a router. But with multi-layer switching, all you need is a layer 3 switch or a multi-layer switch like this one right here, a 3560 switch. And this switch can handle all of the switching duties, the VLANs, and also do routing. Let's see how it works. So I have this laid out. We've got a PC here, PCA, and this is what the IP address is going to be right here. And this PC will be in VLAN 10. We have another PC over here, and this is going to be its IP address, and it's in VLAN 20. You can see the switch ports that it connects to on the multi-layer 3560 switch. Also, going from the switch's gigabit 0/1 interface, we're going out to our ISP. Notice we don't need a router on our network because the multi-layer switch is going to handle the routing and the switching, and then it will go out to the ISP. So I chose a 1941 router to represent our internet service provider. The connection's on gigabit 0/1, and we're going to need to set up this IP address for the internet service provider. The cloud over here is doing nothing. I just put it here to represent that this is where the internet is over here, let's say. Okay, let's start configuring this. To start with, let's set up our addressing. So I'll go to PCA and put in this addressing. We're going to need a default gateway of 192.168.10.1, and I'll get back to that in a minute. And over here, PCB is going to be in a different subnet, 192.168.20.100, and its default gateway will be 20.1. All right, so I've configured PCA and PCB in separate networks, the 192.168.10 network for VLAN 10 and the 192.168.20 network for VLAN 20, and they're both host number 100. Now I'll move over to the ISP. Now the ISP is going to have a public range, let's say IP address, and we'll set that up right now. Go to the command line interface and go to global configuration mode. Let's put in the host name for it, host name ISP, and I'll go to interface gigabit 0/1 and put in the IP address. All right, the IP address 201.150.10.100. All right, that looks good. Now, for the ISP to be involved in network connectivity tests that we want to run after we set this up, we want it to be able to respond back and, let's say, reply to ping requests. And to do that, it's going to need some type of route to route back to these two subnets. So we're going to give it a default route that points back towards the 3560. So we'll just do that right now. IP route, and we'll put a quad 0 route in here going out of its gigabit 0/1 interface. Okay, so now we have the route and the interface up, so we're all done here. What I'll do is Control C, and I'll save my configuration with a copy run start command. All right, now the ISP configurations are finished, and now we can focus on the multi-layer switch here in the center. So I'll click on the switch, select the command line interface, and we can start configuring. I'll type EN for enable and conf T to get to global config mode. Let's put in the host name S1 the first thing I'm going to want to do is create the VLANs. So I need a VLAN 10, and I also need a VLAN 20. I'll do a Control-C and a show VLAN command to take a look at the VLANs. And you can see right off the bat that we have a VLAN 1, which is the default VLAN. It's active, and all the switch ports are currently in VLAN 1. There's our VLAN 10 and our VLAN 20, but none of the switch ports are in VLAN 10 or VLAN 20. Now we need to put switch port 1 in VLAN 10 because that's the switch port that's connected to PCA, and we need to put switch port 10 in VLAN 20 because that's the switch port that's connected to PCB. So let's do that really quickly. I'll type in interface F0/1. It takes me into switch port 1. I'll type switch port mode access, and then switch port access VLAN 10. So now switch port 1 is in VLAN 10. I'll do the same thing, up arrow, go into interface fast Ethernet 0/10, and switch port mode access, and switch port access VLAN 20. So now switch port 1 is in VLAN 10, switch port 10 is in VLAN 20, so now if PCB and PCA wanted to communicate with one another, and even if PCB changed its IP address to 192.168.10.101, let's say, they would not be able to communicate with each other. Just to demonstrate that and verify that, I'll try to ping 192.168.20.100, and you can see that it's not going to work. They're in separate VLANs, and there's nothing to route between the two VLANs, so that's going to be impossible. So if we want to route between VLAN 10 and VLAN 20, we can turn on IP routing on this switch, and we can make the switch basically the default gateway for VLAN 10 and make the switch the default gateway for VLAN 20. Let's do that. So I'll go back into the switch, and essentially to make the switch the default gateway for PCA and PCB, what I'm going to do is I'm going to put IP addresses on the switched virtual interfaces for VLAN 10 and VLAN 20. To do that, I'll type in int for interface VLAN 10, and that will put me into switched virtual interface for VLAN 10, and I can now type in IP address 192.168.10.1 and a subnet mask and a no shut command, and now the switch is 192.168.10.1 on interface VLAN 10, which is a virtual interface, a switched virtual interface that anybody in VLAN 10 can communicate with. And then I'll do the same thing for VLAN 20. I'll say interface VLAN 20, put in the IP address 20.1, and then a no shut command. And now we should have both of those switched virtual interfaces. Let's take a look. I'll put a show run command in here in privileged user mode, just to see what we have so far. There's our interface VLAN 10 with IP address, our interface VLAN 20 with IP address. We can see that switch port 10 is in VLAN 20 and switch port 1 is in VLAN 10, but we're still not able to communicate with each other on separate networks. If I ping 20.100, you can see that the ping does not reply. To get the multi-layer switch to start routing between the two subnets, what I need to do is, I'll just get out of here. Let's go back into the switch, get to global config mode, and type in the command IP routing. Now it should work. We'll go back to PCA, go back to the command prompt, ping 20.100, and see if it starts working. Oh, there's a reply. So with the simple command IP routing and the two switched virtual interfaces, the switch is now able to route between the subnet for VLAN 10 and the subnet for VLAN 20. But that's not all. Another benefit of multi-layer switching is that we can turn a switch port into a routed or router interface. And what we're going to do is we're going to do that for gigabit 0/1. So on this interface right here, gigabit 0/1 on this multi-layer switch, what I'm going to do is I'm going to give it an IP address. Now normally on a layer 2 switch, the IP address only goes onto a switched virtual interface. But with a multi-layer switch, you have the ability to turn the switch port into a routed interface. Or into an interface. So what I'll do is I'll type in 201.150.10. Let's say 101/24, and we'll put this IP address on the gigabit interface. Now to do this, I'll go back into the switch, and I'll say interface gigabit 0/1, and then put in the command no switch port. Notice that when I put in the no switch port command, you can see that the line protocol on gigabit Ethernet 0/1 changed state to down and then went back up. Now I can put an IP address directly on the interface, just as if it was a router interface. So I'll put in the address 201.150.10.101 and the subnet mask, and then a no shut command. And now I have an IP address on that interface. I'll also put a default gateway, IP default -gateway. I'll put it to the ISP's, let's say, IP address. So 201.150.10.100. All right. So now, not only do we have routing between the two VLANs, the two subnets here, but we also have turned the switch port gigabit 0/1 interface into an interface, into a routed interface, and we should be able to ping the ISP from our two PCs. Let's give it a try. I'll go to the command prompt and type ping 201.150.10.100. And you can see after ARP resolves the MAC addresses that are necessary, we get a reply from the ISP. And I should also be able to do it from PCB. We'll open up PCB here, type ping, and I should be able to ping the ISP. Not only that, I can also ping 192.168.10.100, and I can ping from VLAN to VLAN, subnet to subnet. So now, instead of having to configure a layer 2 switch and a layer 3 router, I've configured this multi-layer 3560 switch to handle routing and switching, and also turned a switch port into a routed interface to go out to the ISP.